This is your second Chapter 1 review video. I will be working the next section of your review today. So all of these equations are two-step equations, so this is just an extra, we're taking it a step further this time rather than what we did on the last video, which was one-step equations. So we're going to start out just solving two-step equations that are already written for you, and you can always check your solution, remember, by plugging that value in for the variable once you find it and making sure that the equation is actually equal to whatever it says it's equal to. Okay, so I'm looking at number 15. Hopefully you already have your review out. If not, pause the video and please get it out. On number 15, notice that we have 18x minus 14 on this left side of the equation, and then it equals negative 14. So when you do this, if you think about it and you're covering up one side of the equation and just look at the side that has the variable, you always want to move the constant, which is the number without the variable, to the other side to start with. So the opposite of minus 14 is plus 14, so I'm going to add 14 to both sides. Now I noticed when you guys did this, I don't remember if it was on a quiz or another assignment, but notice on the right side when I do negative 14 plus 14, I get 0. Some of you, whenever you got 0, you weren't really sure where to go from there. So I want you to think about what you see. So this says 18 times x equals 0. Well, you can multiply 18 by a number that would give you 0, and that number would be 0. Anything times 0 is 0. But if we continue to solve this like we normally would, and we divide both sides by 18, because that's the opposite of multiplying, 0 divided by 18 is actually equal to 0. So I know that x would be equal to 0. Now remember, you can always check that. You just take 0 and plug it in right here. Well, 18 times 0 is 0. Minus 14 equals negative 14. So I know I did this problem correct. Okay, let's look at number 16. So for number 16, notice we have 3g plus 5 on this side. We need to get everything moved to the other side away from g, because we're trying to isolate that. So the opposite of adding 5 would be to subtract 5 from both sides. So positive and negative 5 make 0, and I bring down my 3g. 20 minus 5 is 15. Now the opposite of multiplying by 3 would be to divide both sides by 3. 3 divided by 3 will leave me with g by itself, and 15 divided by 3 is 5. So I find out that g is supposed to be equal to 5, but let's check it. So I'm going to take this 5 and I'm going to put it right there where g is. 3 times 5 is 15, plus 5 is 20. So I know I did this problem correct also. Okay, so notice 17 and 18 are very similar. They have some division, which you guys see, those are written as fractions. Remember, a fraction is just a division problem. But when you look at these problems, like for number 17, this looks very similar to what we were just doing. So you see that minus 10, and you know you need to get it to the other side away from x. So that's where I'm going to start. The opposite of negative 10 would be positive 10, so I'm going to add 10 to both sides. And I'm going to bring down my x over 7. Now notice over here on the right side, some of you are still struggling a little bit with your integers. When you are adding and you have two numbers with different signs, you actually wind up subtracting and taking the sign of the larger number. So negative 8 plus 10 is equal to 2. Okay? Alright, from here, the opposite of dividing by 7 would be to multiply by 7. Remember, whatever you do on one side, you have to do to the other. So 7 over 7 makes 1x, and 2 times 7 is 14. So once again, we'd like to check to make sure we did that correct. So we're going to take this 14 and we're going to plug it in right here where x is. So 14 divided by 7 is 2, and 2 minus 10 is equal to negative 8. So we know we did it correctly. Alright. If you look at number 18, it is slightly different from all the other problems. It's different because the constant is trapped up here on top of this fraction. So I can't move the 2 first. I have to deal with this divided by 3. So the opposite of dividing by 3 is to multiply by 3, and 3 over 3 would make 1. And then I have my variable, which is z plus 2, and that would equal, and don't forget, if you multiply on the left, you got to do it on the right. 6 times 3 is 18. Now it looks like the problems we did on the first video. It's just a one-step equation, and the opposite of adding 2 is subtracting 2. So I'm going to do that from both sides. I'm going to bring down my z, and that equals 16. Some of you asked me why I draw the line. I just draw my line through my z because it looks very similar to my 2's. So if you ever see me do that, you know that this is a z, and look, right there, that's a 2. Okay? So let's go ahead and sub in right here to check our work. 16 plus 2 is 18, and 18 divided by 3 is 6. So I know I did this one correctly also. So on this second section, what you should notice is now instead of just having one variable, we've got some combining like terms that needs to happen. See, we have 2 different terms with w's, we have 2 different terms with u's, x's, and q's. So this is something that we did the first week of school where we had to combine like terms before we start moving things across the equal sign. So if you want to think about this like you're covering up one side of the equation so that you can clean up the other side. So I'm not moving stuff across the equal sign yet, so I can just do the math that you see. So we have 7w's plus 6w's, which is 13w, and that equals 26. So all I did was combine like terms. Remember, you combine like terms when they're on the same side of the equal sign, okay? So now is when I'm going to use my inverse operations. So the opposite of multiplying by 13 would be to divide by 13. 13 divided by 13 leaves me 1w, and 26 divided by 13 is 2. So at this point you could plug in 7 times 2 is 14, 6 times 2 is 12, and 14 plus 12 is 26. Okay? Alright, let's go ahead and see if you can pause and do number 20 on your own. Okay, so if you look at this problem, the first thing that I did, just like on number 19, I had 11u minus 5u on one side of the equal sign. So I covered up that and I had to clean up my problem. Well, 11 minus 5 is 6u, and then that equaled 24. Then the opposite of multiplying by 6 was to divide, so I divided on the right. 6 divided by 6 made 1u, and 24 divided by 6 is 4. You could always plug in 44 minus 20 is 24. Okay? Alright, so let's look at 21. So 21 is slightly different than 19 and 20 because not only do we have x's, but we have a constant that we're dealing with too. So I'm only looking at the left side of this equation to clean it up to start with, and I'm going to start just like I have been by combining like terms. Now notice I circle mine, so I have 8x's, and then I have minus 2x. When you circle your variables, make sure you circle the sign in front of them. So 8x minus 2x is 6x, and I still have that minus 3, and it equals 21. Once you get your problem cleaned up on the left, you can start moving things around using your inverse operations. So the opposite of minus 3 is plus 3. So I'm going to add 3 to both sides. Positive and negative 3 will cancel, and I bring down my 6x. 21 plus 3 is 24. So notice this is very familiar. We just did that up here. So the opposite of multiplying by 6 would be to divide both sides by 6. 6 divided by 6 cancels, and x is equal to 24 divided by 6, which is 4. Okay? Alright, so let's see if you can pause and do 22 because it's very similar to 21. So on this problem, I circled my like terms that were on this left side. 7q plus 5q is 12q. I brought down my minus 17 equals negative 5. The opposite of minus 17 is to add 17 to both sides. Those cancel to make a 0, and I brought down 12q. Negative 5 plus 17 is 12. Then the opposite of multiplying by 12 was to divide by 12, and 12 divided by 12 is 1. And then 12 over here divided by 12 left me with that 1q. Okay, so far we've worked 8 problems. The first 4 were just two-step equations, and then these next 4, they dealt with the combining like terms, then you had to move stuff around. So now what we're going to look at is some word problems. When you're looking at these word problems, you really need to break it up into parts to make it more manageable when you're writing your equations. Okay, so when I look at number 23, I see a mechanic charges $43 per hour for labor. So that's important. I need to know that they charge $43 per hour for labor. And $217 for parts. Okay, so that's the first part of important information. Then it tells me my total bill is $432. We're trying to find out how many hours the mechanic worked. So when you write your equation, you really want to focus on the expression part, and if they give you a total, that's going to be what it equals. So here, if it's $43 per hour, that means you have to do 43 times the number of hours of labor, plus the $217 they charged you for parts. They told us our total, so equals $432. Okay, so there's my equation to start with. Now, since we've already reviewed solving two-step equations, I'd like you to pause the video and solve this and then check your work with mine. Alright, so when you solve this equation, remember you do the opposite, so I subtracted 217 and then I divided by 43, and I found out that this mechanic worked 5 hours. Okay, let's look at number 24. So it says there are 158 students on a field trip. 5 students traveled in cars and the rest traveled in 3 full buses. How many students traveled in one bus? Okay, so let's kind of break this up. We know that we've covered 5 of the students, and we know that the students who rode on buses rode on 3 full buses. Okay, so what that tells us is our expression part is that sentence that I just underlined. So I know that the total number of students that I'm working with here, so I'm going to solve this over here, is 158 students. Okay. What I also know is that 5 of them traveled in cars, plus there were 3 buses with a certain number of students on them. Okay? Alright, so now we can solve. It's a two-step equation, so let's go ahead and pause. You guys solve this, and then we'll come back and talk about it. So on this problem, probably the part that would throw you off is this part right here where I have the 3x. So notice it says 3 full buses. So that's why I did 5 students plus 3 buses times the same amount of students on each bus. Okay, so that's where that came from. So when I solved, I did the opposite. So I subtracted 5 from both sides and divided by 3, and I found out that 51 students would fit on one bus. Okay, let's see if you guys can pause and write the equation for number 25 and solve it. Then you can restart the video and check your work with mine. Okay, so on this problem, the key was that those teachers bought 6 boxes of candy bars, and we know that they sold an additional 540. So each box would have to have the same number of candy bars in it. So that's where the 6x came from, 6 boxes of however many candy bars, plus the additional 540 had to equal the total amount they sold, which was 810. Do the opposite, so subtract, then divide, and you find out that each box has 45 candy bars in it. Okay, so this video is a little bit longer. If you have any questions and the video doesn't help, please make sure you come in for tutoring. Have a great night.